not this stew again. Hello, Hunter. How can I help you today?
I'm a little confused on the Brad essay. Do you think you could help me?
First of all, it's the Bradford Assay, and...
Yeah, that's it!
Right. As I was saying, yes, I can help you. Let's go ahead and head to the lab. Put on your lab coat first. See, I have mine. So, can you tell me what you know about the Bradford Assay?
There's stuff in it, and when you put more stuff in it, it turns blue, right?
Okay. Well, that's better than nothing. So the stuff that you mentioned is protein, and the Bradford Assay is used to measure the concentration of protein. Basically, the Bradford Assay answers the question, how much protein is present in my sample?
You know, my favorite color is blue, but I like some other ones too.
Okay, that's nice. I'm glad to know that about you. But let's go ahead and start talking about the experiment. The first thing that we need to do is understand our materials and what they are. We're a very underfunded lab, so they look a little funky. Here we have the spectrophotometer. I shouldn't lift it, it should be heavy, but that's okay. Here we have our Bradford reagent. Here we have cuvettes and parafilm. And here we have a pipette and tips. Hunter, there's no food or drink in the lab. Put it away. Perfect. We're leaving it. Okay, so the air conditioning seems to be broken, and you have already taken a drink of water. So we're just gonna go ahead and take off our lab coats. And you're not supposed to do that, so just remember that. That's bad lab safety. And so I'm going to go ahead and prepare the materials. If you could open up the cuvettes, please. So like I said before, our materials include the parafilm, the cuvettes, Bradford reagent, pipette, and spectrophotometer.
Oh, I got a spec photo.
A what?
Spec photo.
That's a fish.
What else would it be? What else is a spec photo?
I said a spectrophotometer. Spectrophotometry is a way to measure how much light is being absorbed by a substance, and it works by measuring the intensity of a beam of light as it passes through a liquid or sample. This is how we're going to determine the amount or concentration of protein in our sample.
I really thought we might be working with fish at that point.
If you want to work with fish, you might want to consider being an ecology major.
It's okay, I'm almost done. There ain't no point switching now, I guess.
Right, well, continuing on, first we're going to add, so we have 7 cuvettes, and these are going to have the standards. Then we have 1 which will be a blank, and 1 which will be for our sample. And so the first thing that we're going to do is add the Bradford reagent to all of our cuvettes. So we add our Bradford reagent.
How much?
1 milliliter in each cuvette. So the Bradford reagent contains Kumasi G250 blue dye.
Who? There's a kid in my school named Damasi.
No, Kumasi dye. It contains, certain amino acids on a protein will react with the dye and allow the protein to absorb blue light, because normally we can't see proteins. But this dye attaches to the amino acid side chains and lets it absorb blue light. And so the more protein that's present, the more blue the sample will appear. and ones that don't have a lot will turn brown.
So the more the bluer.
Yes. So once the 1 ml of Bradford reagent has been added, we're going to add 20 microliters of protein standard to each of these 7 cuvettes, because we have 7 protein standards at varying concentrations of protein. So the protein standards basically serve as a point of reference. We already know the concentration of the protein in each standard and what to expect from them. The concentration is measured in milligrams per microliter. So like I said, we're going to add the 20 microliters of our reagent into our sample one after the 1 ml of Bradford reagent. But for these 7 protein standards, we're going to add 20 microliters of each protein standard. So like for the first protein standard, 20 microliters of it, 20 microliters, 20 microliters, etc. And then we'll add 20 microliters of PBS into this cuvette to serve as our blank. And then we'll add 20 microliters of our sample into this cuvette to test. So let's go ahead and do that. Notice the immediate change in color as it gets less and less brown, and it starts to get more and more of a nice blue. Wow, look how nice this blue is. And so now we're going to add our 20 microliters of PBS to serve as the blank, and then 20 microliters of our protein of interest. Okay, so now we're going to let them sit at room temperature. First we're going to gently invert them after we add our parafilm to them. So we invert it. Don't squish it. Invert it. Or you can also vortex, but we are very underfunded and we don't have a vortex. So we just invert them to make sure it's all nice and mixed. Parafilm is very useful, as you can see. Okay. So now that we've inverted all of our samples, all 9 of our samples, we are going to let them sit at room temperature for 10 minutes.
Wait, how long?
10 minutes. 10 to 15 minutes, actually. But
So we're just supposed to sit here and stare at it?
no, I actually have a video for you to watch that I think will help you to better understand the material in a little bit more detail.
I didn't come for class.
So if you could continue on into the office and go watch the video. And then I'll come get you after 10 minutes.
Thank you for tuning into Lab U from Pipette, New Mushroomton. I am Professor Terbium, and today we will be discussing the Bradford Assay. The Bradford Assay is a quantitative measurement that measures the concentration of the protein within your solution. Once you have isolated your protein of interest in this solution, we will add the Bradford reagent. Most organic compounds are very clear, and so are proteins. So we must add a dye that attaches to the protein in order to see the concentration. In this case, we will use Kumasi blue dye. The Kumasi blue dye binds to the protein, making a dye-protein complex. Under acidic conditions, the dye will be a reddish-brown, kind of like a cherry wood color. And then once it binds to the protein, making this dye-protein complex, it turns a nice bright blue, just like the color of my shirt. The dye forms a strong non-covalent complex with the carboxyl group of the protein and creates an electrostatic interaction with the positive amino group. This interaction creates pores within the quaternary structure of the protein, so the positive amino group is exposed to the negative region of the Kumasi blue dye. This stabilizes the dye, which then creates that blue color, just like my shirt. Using a spectrophotometer, at this case we'll use an absorbance at 595 nanometers. We'll first blank it, and then you will measure your protein standards of concentrations. So the protein standards of concentrations that we use here is bovine concentrations, which are cattle proteins. We use those and PBS to blank it. Once all the measurements are recorded, you'll have your table. So we'll say, I don't know, we'll use standard one will be what? Your 0.125, your 0.25, and 0.5. And we'll throw some numbers. So for the first one, we'll say we get, actually, let's see if I can find some data here, because we've been doing an experiment ourselves. So we will look and we'll say what? 0.4 for 0 will be 0. And then we'll say 0.5 is 0.8, right? So you'll have your table, X and Y's, and we'll go ahead and do a scatter plot. You usually do this within Excel. And then, so we'll just kind of scatter. So that's what your scatter plot will look like. Then we'll do what we call a trend line, and that takes the average of your points and finds the most linear line to hit the most points. I just drew it randomly. If you do this in Excel, it does that for you. Once you get your line equation, y equals mx plus b, you isolate y to 0 as it crosses the y-intercept, and then you solve for x. Once you solve for x, that's going to give you your protein concentration. Now don't forget your units, milligram per milliliter. Professor Turbium, what do you mean the QC is not working? Which Cobos machine? 2, I just had that fixed and the technician out. Are you sure you're adding the right reagents and everything and you're clearing the screen and resetting it? Okay, I'll be right there. So that concludes the Bradford assay. Evidently we're having some quality control testing problems in our lab, so I have to run over there and take care of it. But I hope this video summarized the Bradford assay and you learned a lot more about the Kumasi blue and how it interacts with the proteins. And for now, just remember to always use your units, as well as safety first, lab coat, mask on, hair is back, water stays in the office as there's no food and drink in the lab, and as always, science can be fun if you know how to investigate it. Enjoy your day, and thank you for tuning in.